Hello everyone, this is Professor Kuehn. In this physics course, up until this point, we've been studying the work of, first of all, Galileo, and then the work of Blaise Pascal. We're going to put behind us the work of Pascal and begin studying the work of Isaac Newton. So Isaac Newton lived around the same time as Pascal, just after Pascal actually. So Pascal died in 1662. Newton was born in 1642, so they overlapped by a little while. Newton died in 1727. And before we talk about the specific scientific work of Newton, I want to begin by giving a few more biographical notes about him, because I think really to have a good understanding of Isaac Newton, you have to understand the historical context in which he was working. So here we go. So Newton was a student at Cambridge at Trinity College, and actually there was a plague during this time between 1665 and 1666 while he was a student at Cambridge, and he was forced to suspend his studies. And when he did that, he went to his family's home in Woolsthorpe, which is about 60 miles from Cambridge. And he lived there for a couple of years on his family farm until the plague died down. So during this time, what Newton did is he developed what he called his method of fluxions. This is just a mathematical technique that would later lead to the development of calculus. You might recall that Newton and Leibniz were contemporaries, and they both developed calculus independently. In 1687, Newton published probably his most famous work. It was called his Mathematical Principles of Natural Philosophy. It's a very long title, right? So a lot of people just call it his Principia or Principia, depending how you pronounce it. So the Principia, that's probably what I'll call it most of the time, but the longer title is Mathematical Principles of Natural Philosophy, and it will become clear why he called it that after we discuss it for a little while. So a few things about this book. So first of all, the book, it went through 3 different editions. The first one, like I said, was published in 1687. The final edition was published right around the time of his death in 1726. So how is the Principia organized, and what's the goal of the Principia? Well, the Principia consists of 3 separate books, Book 1, Book 2, and Book 3. So let me tell you a little bit about what's in each book. So in Book 1, and this is where we are going to start in this class, Book 1 begins with, first of all, there's an author's preface where he talks about what his intention is in this, and we'll spend a few minutes talking about that. And then in Book 1, he begins with definitions. So he defines what he means by terms like inertia and momentum and force and so on. So it's, keep in mind when you're reading his definitions that just because you define something doesn't mean it exists, right? So when you give a definition, you're simply saying, when I use this word, this is what I mean by the word. So, you can define a unicorn to be a horse with a horn, but that doesn't mean a unicorn actually exists, right? So you should take his definitions as simply him defining his terms. When he uses a term like inertia, this is what he means by that term. Okay, and then he's going to have to argue that it's a significant thing or it's important, but just the definitions are how he's going to use terms. After going through these definitions, then what he does is he lays out his 3 axioms, and those are now known as Newton's 3 laws of motion. He didn't call them Newton's laws of motion. He just called them Axiom 1, Axiom 2, and Axiom 3. You might recall what an axiom is. So you've probably come across the word axiom perhaps in your geometry courses. An axiom is something, it's a starting point that either everyone agrees on, sort of a conventional starting point, or it can also mean something that's just commonly understood to be true. It's just self-evidently true. And it's not quite clear at this point what he means by axiom, but he's going to lay down his 3 axioms, which are, like I said, his 3 laws of motion. And then for the remainder of Book 1, what Newton does is he derives a number of propositions and theorems and corollaries that follow from his axioms. So you're going to notice that this reads kind of like a math book. So if we assume these 3 axioms to be true, what kind of properties can be derived from assuming the truth of these axioms? And in particular, he's going to be interested in what kinds of motion will bodies exhibit when subjected to different kinds of forces. Okay, so that's going to be a lot of what Book 1 of his Principia is about. In Book 2, what Newton does is talk about the motion of bodies. He focuses on when bodies feel more complicated forces, for instance, drag. So when an object is immersed in a fluid and it's moving or falling or being shot through a fluid, it experiences drag, and he's going to work out the consequences of his laws of motion for these more complex scenarios. We are going to entirely overlook Book 2 of Newton's Principia. We're not going to focus on that at all. We will look at some of Book 3. And Book 3 is called The System of the World. And in this Book 3, what he does is he applies his 3 axioms, or his 3 laws of motion, in order to understand the motion of the planets, the sun, and the moon. And it is in this chapter that he develops what is now known as Newton's universal law of gravitation. And so maybe I should say one thing about that before I continue. Up until this point in time, as you'll remember, from the work of people like Pascal and Galileo, people had been talking about gravity before Newton, but they meant something very different than Newton does. So, for example, when the ancients and the medievals and even up through Galileo talk about gravity, they mean kind of the terrestrial or the heaviness or the weight of an object. So a baseball has gravitas or gravity because it tends to fall to the ground. It's not really seen as a force that the earth pulls on the baseball with. It's just meant to be sort of a property inherent in objects. They have gravity, and that's why they fall to the ground. You might recall that some objects were seen to have levity, right? So people like Aristotle and their followers believed that air does not have gravity, it has levity, and that's why it tends to go upward, okay? So that's a traditional way that people had been understanding the term gravity. Newton is going to approach it in a very different way, and that's what we're going to be developing over the course of the next few weeks. Just a spoiler alert, what Newton is going to say is that gravity is a force that acts between two objects. So for example, the earth is going to pull on a baseball, and that's the cause of the gravity that makes the baseball fall to the ground. And likewise, a bit counterintuitively, the baseball is also pulling on the earth with the exact same force of gravity. So he's going to develop that kind of idea. But it's a very different view of gravity than people had before. So those are the three books that comprise Newton's Principia. Newton's Principia was written in Latin, and it was translated into English. There was a later book that Newton wrote called his Optics, and this one we study in my other class, Electricity, Magnetism, and Light. We read selections from Newton's Optics. This was written in his native language of English, not in Latin, but the Principia was written in Latin, so we're going to be reading an English translation of a Latin text. In Newton's Principia, like I said, it reads a lot like a mathematics book. So he has these axioms and these propositions that follow from the axioms, but there occasionally are digressions into topics of more speculative or philosophical and even theological nature. And these digressions are called Newton's Scolia. So he says this is a scholium on this topic or that topic. And it's kind of like Newton is cracking open a beer and sitting back and talking about the meaning of what he's been saying. So it's a little bit more philosophical and sometimes theological and speculative. So that's what you'll occasionally come across, these scholia. And so we will spend some time talking about Newton's scholia as well. Newton is very interested in relating the work that he is doing to previous work. So at this point, I think it's important to provide a little bit of background on the state of science, or as it was called at the time, natural philosophy, at the end of the 17th century, that is in the 1600s, at the time that Newton wrote his Principia. And it's hard to truly understand the work of Newton, or Galileo, or Pascal for that matter, without understanding some of this historical context. So there had just been, around the time of Newton, a little bit before Newton, a major change that was introduced by the French philosopher Descartes and also Galileo regarding how one should even think about nature or natural philosophy. Before Descartes and Galileo, the study of natural philosophy was shaped largely by the thinking of the ancient Greek philosopher Aristotle. Descartes and Galileo, and Newton and Pascal for that matter, were very well versed in the thinking of Aristotle. They read his works and they understood what he was saying, but they rejected a number of the Aristotelian ways of thinking. Descartes and Galileo rejected a lot of the kind of categories in which Aristotle was thinking. So what I want to do is spend a little bit of time giving a tour of some of the most important, at least for our discussion, the most important ways that Aristotle thought about nature. So I'm going to spend the next couple of short lectures reviewing Aristotelian natural philosophy. So I'm going to stop here, and at the beginning of the next lecture, I'm going to give a brief review of Aristotelian natural philosophy.